do number 20 on the 2004 mechanics multiple choice test. 2 blocks of mass big M and little m, with big M being bigger than little m, are connected by a light string. The string passes over a frictionless pulley of negligible mass so that the blocks hang vertically. The blocks are then released from rest. What is the acceleration of the block of mass m? So this is a classic Atwood machine problem. So you have a pulley with a block m, little m, and so we want to know what is this. It's going to accelerate down, right? I mean, if m is bigger than little m, this pull is going to be greater than this pull of gravity, so you're going to have a acceleration down. And we didn't cover this kind of problem, and it's and I like to straighten out the free body diagram. Is what I like to do. So I'm gonna make this one free body diagram. So I'm gonna take this guy and go whoop, just rotate it 180 degrees, like that. So here's big M and here's little m, and I can do this in my imagination. Now gravity is pulling this guy down with little mg, but in my pretend world, gravity is now pulling this up. Whereas gravity is pulling this down with big mg. Okay. Well, this is my free body. So if I sum the forces in the y direction, let's let down be positive y. We can do that. It's equal to ma. Well, that's what I want to find. Well, let's sum the forces. I've got mg minus little mg is equal to, well, what's the total mass? This is the mass of the free body. It's m plus m times a. So I take this equation, solve it for a. I'll do it down here where I got more room. A is equal to, well, let's factor out g. It's going to be m minus m, little m, times g over m plus m. And that's choice E. So the correct answer should be E. Now, let's say you don't have time for that, or you forget how to do that, or you're just getting kind of lost in it. How do you make an intelligent guess? Well, first of all, G doesn't make any sense. I gotta eliminate that one. It's going to be slower. Now, if it's going to be slower, look at answer C. M plus m divided by m. Do you see that this number is going to be greater than 1? So therefore, it's going to accelerate at a rate greater than gravity? I don't think so. Now this one, m plus m over m minus m, once again, this fraction is greater than 1. It's not going to, no. So now it's between these two guys. Now this is less than 1, and this is less than 1, so either one of these answers would be a reasonable guess. But now you're down to 50-50 if you're guessing instead of 1 and 5. Okay? You kind of see how that works? Big idea for this problem? Well, make sure you can draw a free body diagram. For pulleys. When you have a fixed pulley, you can straighten out the free body diagram and turn it into one thing. If you try to draw a free body diagram of this guy and a free body diagram of this guy, you can do it, but you're going to have two equations and two unknowns, and it's going to be the tension in the string It's going to be one unknown, and the acceleration is the other unknown, and it's going to take you a long time. It's going to take you more than a minute and 20 seconds or whatever you have per problem to do. And that's fine if you're going to get it right. But straightening out the free body diagram like this is a good trick. Okay. Any questions? Okay. That is all.